Well, good morning, and I too want to thank the organizers and my fellow panelists and other speakers for this very interesting meeting and this very interesting session. I was extremely impressed by the presentations by Professor De La Lera and Mr. Toro of the Emergency Management Service on the maturity of the Chilean enterprise for resilience and risk reduction. Not just locally in Santiago, but nationally as well. I am very impressed by the way the different elements of academia, of government, of the private sector are being integrated, and that, in some sense, is going to be the conclusion of my talk. I'll be covering a lot of ground that has already been covered already, but I'll give you, I think, somewhat of a perspective. I started work as a theoretical seismologist, and more than 40 years ago, when I began studying earthquakes, some of the first papers I read were about the 1960 earthquake in Chile. In addition to energizing some of the discussion about risk and earthquake safety, that earthquake created an entirely new field of theoretical seismology, which has really come to dominate our understanding of the planet as a whole. It had very significant consequences, in addition to what it had locally. But as we have developed our understanding of earthquakes, earthquake monitoring, what we have lagged, what we have not been able to do, is to develop an understanding of the risks associated with different extreme events. And that, of course, leads me again to what has already been discussed, the situation in Italy. As we stand here, rescue operations are underway. My expectation, the expectation of many folks in this field, is that the casualty figures, the deaths from this earthquake, will rise into the thousands quite easily, if not more, and the damage will be substantial. And for the reasons that have already been discussed by my co-panelists, there are a lot of lessons to be learned and a lot of understanding to be made as to why this earthquake, which is actually not great, it's just large, it's just a magnitude 6.2, many thousands of times smaller than what you see here in Chile. Why did it have such an impact? And we know, of course, that Italy, of course, has many earthquakes, so this is firmly understood. Buildings in the affected area, in fact throughout Italy, have been in place for centuries, many of these from the Middle Ages, and their construction practices and so on derive from that. And while there are building codes affecting new buildings, as had already been pointed out, retrofitting the old structures, which are not only historic, but in fact a source of cultural pride, has been lagging. And this event, of course, occurred in between two previous events, one in 1997 and of course, the L'Aquila one in 2009, both of which have interesting characteristics that I can comment on. So it is not as if this region was unaware of the potential for extreme damage. But it brings me to this point, which is, in some sense, comically called as Bilham's Law. This is a colleague who works at the University of Colorado who first made this plot to look at the deaths per earthquake in a logarithmic scale, powers of 10, against earthquake magnitude, which is of course in powers of 10, and to show, in fact, that not only is this general increase, as one would expect, but there is a wide amount of variance across that diagram. Which brings to point that extreme events, in fact events in general, have implications, have effects and impacts that are not necessarily tied to the geophysical and what causes that variance. There are many ways of thinking about it. If we look at Haiti in 2010, one could generally talk about the poverty of that nation and its ability to respond in addition to its disaster preparedness or lack of disaster preparedness. But if we look, of course, at Chile after the Maule earthquake, that in fact is the type example of what good response and relatively good preparedness can do for you in a situation like this. Tohoku, deserving of another another talk, as it were, illustrates not just the geophysical implications of extreme events, but what can happen when there are cascading failures associated with institutional management, or I should say institutional mismanagement. We first tried to get a look at this. This is a map that actually goes back almost 15 years now and was published in 2004 and 2005. This is a study we did with a number of colleagues for the World Bank to try to look at the multi-hazard aspects of the global phenomena and to try to assign some sense of economic loss. The data is not very good. We had to work to, as it were, a lowest common denominator for the data. But we tried to look across a spectrum of hazards. This study was done in 2004, actually, or completed in 2004, well before the Indian Ocean tsunami, and in fact, we didn't include tsunami in this particular calculation. But what we came to understand is that more data is needed. That's effectively the outcome of this, and one has to drill down, emphasize the specifics of individual hazards in much more a way to understand the effects of extremes and understand the effects of just ordinarily large events. One of the other things I want to point out, and what was illustrated in one of the earlier talks, is that hydrometeorological disasters, storms, floods of that sort, typically have greater insurance losses, which points not to a loss factor, but more to the way business is being done with respect to sharing the risk for different disasters. And that bears some investigation as you engage in the process as well. So we've seen several definitions of resilience, and this is one that one of my co-speakers, Susan Cutter, who led a U.S. National Academy panel on this matter a number of years ago. Resilience is the ability to prepare and plan for, absorb, recover from, and more successfully adapt to adverse events. And some of the issues that were raised in that report, and I commend that report to you if you are not already familiar with it, is that there are issues of resilience pertaining to the short term, having to do with events themselves, or the long term, having to do with more emergent disasters or more emergent hazards, such as climate change and sea level rise. There's also the issue of geographic scope, ranging from the very local or the urban scale to the national, the international scales as well. Links to sustainable growth have already been mentioned in several contexts as well. How can resilience contribute, and is it a factor to sustainability? And avoiding the recovery gap, that is the notion that after an event in particular, particularly with the investment that comes in recovery, is that investment sufficient to recover the growth trend, and isn't in fact sufficient to overcome the initial, and in fact, as it were, to quote several of my colleagues, build back better. And of course, there are other factors pertaining to the overall resilience issue, including the perception and response to risk assessments, which has already been covered by the previous speaker. A study by IASA in Vienna actually makes the point about this recovery gap. This has to do with Honduras, but here you see, of course, real data having to do with GDP after Hurricane Mitch and associated other events. This is what we mean by the recovery gap, the notion that even after investment in recovery, one doesn't get back to the trend line associated with normal economic growth. And that can be a factor over the long term, probably less so in Chile, but more so in developing countries. But we also see, and again, another study by Reinhold Meckler at IASA, some of the impacts going beyond physical damage or related to physical damage. This has to do with transportation bottlenecks after Hurricane Mitch. Before, where the hours to market were generally uniform, but then disrupted, of course, after the hurricane. And the speed with which that disruption is diminished or impacted or replaced is also critical. Recent studies have also shown how resilience or hazardous events can contribute to political instability. This is a study that some of my colleagues at Columbia published in Nature associating drought and climate variability in Syria to the uptick in violence in the Middle East, something that bears more watching. Somewhat qualitative at this point. There's an attempt to make it quantitative, but as we understand the causal effects and actually, again, understand the specifics of this, perhaps we'll have a better understanding of sociopolitical resilience as well. We've already seen this equation, which is a conceptual equation, that risk is a product of hazard, exposure, and fragility. I'll only add that this is what is known as a separable equation. In other words, all we have to do is reduce one of these factors in order to reduce the overall risk. It's hard to reduce the hazard, but exposure and fragility, of course, is something that we can do as a society, reducing that. We need to assess the codependence on growth and development. How does that affect risk? How do we establish uncertainties and thresholds? And one of the issues related to data, the acquisition of data, monitoring, modeling that data, and how does that translate into our predictive or forecasting skill? There are issues of time and space scaling, and I will add that in terms of extremes from a purely scientific mode, as we've already talked about, these are actually very poorly understood as phenomena. It's very difficult to do, and one of the things that we would like to do is anticipate from a scientific perspective, let alone a socioeconomic perspective, what will actually happen during these very extreme events. I actually have stopped teaching theoretical seismology at Columbia, and I now teach to cohorts in our business school and in our School of International Affairs in master's programs in sustainability management and sustainability science. We're developing new curricula in these fields. And what I have found is that when we argue that environmental risk or natural hazard risk and resiliency ought to be part of the spectrum of risk management that any business or any institution has to deal with, we're getting quite a good reception. And what we're beginning to see, at least in our student body, is a realization that these elements of risk management associated with natural hazards and natural processes need to be included in the ordinary spectrum of risk management that industrial managers and government managers actually deal with. And so we look at how that can be done, and we try to describe the basic calculation of risk in terms of management principles. And this is something, of course, that has already been covered. But we talk about some of the objectives that managers need to talk about or need to include in their management principles. And of course, when we talk about risk reduction, the classic objective has always been to reduce the probability of life loss and physical damage and economic and social disruption. This is basically an order of priority right now. An alternative might be, of course, to optimize, that is, to minimize the risk with respect to variable constraints, which in practice is what is actually done, because there's only so much money and there's only so much management talent and management expertise and predictive capability to go around. So the question is, under the optimization ethic, is what is an acceptable level of risk for a given level of economic, political, and social investment? Which set of design parameters among many will deliver that acceptable level of risk, and which designs and institutional structures will improve resiliency, and how will this change over time? Let me emphasize that last point, that risk and resilience are dynamic variables. One has to deal with not only increasing knowledge about extreme events and even large events, but an increasing understanding of the impacts. How are the lessons learned ingested? How is new scientific knowledge ingested into the whole enterprise? We've also found it helpful in talking to risk managers to emphasize this notion of a risk taxonomy, or the notion of sort of a hierarchy or a way of characterizing risk, again in terms of management principles. We talk of emergent risk in the case of environmental risks. We characterize climate change, sea level rise, as an emergent risk, something that is not going to happen tomorrow, but does in fact have a time frame associated with it. And my colleague Lisa Goddard will be talking about that in the next panel. But also in the context of risk, in terms of exposure and fragility, we, as Dr. Rosetta just talked about, notions of urban growth and new infrastructure, new buildings and industry and demographic changes are all elements of the emergent aspect of risk. There's a persistent risk, and this is the notion that there are ongoing events, ongoing systematics in the natural system that are basically persistent, that are basically occurring, for which we have good statistics, good statistical models, which gives us some sense from a scientific point of view that these can be predicted or forecast. And this is the notion that the past gives us some knowledge of how to work in the future. We talk, of course, about extreme event risk, which is known as the high impact, low probability event. Still, as the background in climate changes, for example, we're going to see an increase in the probability of these extreme events for various reasons that I won't go into. But things that, such as maximum magnitude earthquakes, such as the 8.8 in 2010, the collapse of our ice sheets leading to sudden increase in sea level rise. These are difficult to forecast at the moment. We have very little understanding of the precursory phenomena. Perhaps monitoring will help with that. But generally speaking, in terms of the socioeconomic response, it's very difficult to absorb, very difficult to respond. And there are triggered risks and risk cascades, which are part of another discussion. An example of some of the persistent risks and things that can be actually predicted comes from a study in the United States to which many universities participated and which is now being spread around the world. This was conducted by the U.S. Geological Survey and the Southern California Earthquake Center to develop a sense of whether we could assign probabilities to earthquakes in California. It's a very well-studied system, and so one can come up with a probabilistic assessment which has now been entrained or partially entrained, not only in the public sector but also in the private sector, and I think Patrick Ottolini can talk about that later as well. There are examples of triggered risks as well, and these are notions that what happens in nature can trigger impacts or risks associated with man-made enterprises, not just damage, but actually things that need to be managed more effectively. By the way, all of these slides will be made available. The IPCC number 5 report, particularly in its summary for policymakers, talked about communicating these risks, and the notion was to come up with measures of the degree of uncertainty, come up with as quantitative as possible a measure of understanding how much uncertain our predictive capability was, and essentially come up with this traffic-like model where things are bad, things are good, or are somewhat in between. And this depends a lot on probabilistic estimates or understanding of physical systems, some of which simply doesn't work at certain time and space scales. But I think the IPCC erred when they sort of discretized this with too many characters, too many divisions. And so you get this very complex, very difficult to communicate traffic light, which, if this were employed in any traffic system, would cause utter chaos. Which one do you respond to? So the notion is, and still needs to be studied, how do we communicate the different elements of risk, different elements of quantitative and qualitative uncertainty? That has to be a part of the resilience structure. A colleague of mine, now in England, Steve Rayner, first proposed that there was sort of a risk matrix associated with what we know about a system, and here very general systems, all the way up to having no confidence at all, to the stakes in making a particular decision about the evolution of that system, whether it be an event or an emergent risk. And down here in the corner where the systems uncertainties are low and the decision stakes are relatively low, one can apply the rules of statistics or deterministic modeling to come up with a good prediction. This is sort of where short-term weather forecasting is. There are also clinical rules, which are really sort of epidemiology. And if we talk about that, that's really sort of understanding what's going to happen in the future from happening in the past. It's a little bit less dependent on deterministic models, but still has some validity. But as we talk to or go into the areas where the systems uncertainty is very great, where the decision stakes can be quite high, this is the arena of extreme events and their impacts. What we have to adopt is sort of a scenario understanding of what is happening. And we have to, particularly when we're dealing with forecasts or predictions or an understanding that there's going to be an extreme event sometime in the future, but not definitely so, we have to understand what the discount rate is. And I speak of that not just in financial terms, that is, what's the discount for something that we pay for today to reduce our risk tomorrow, but in psychological or risk perception terms. We tend to discount the risks. We tend to discount the need for resiliency for an event that's very far in the future, or perhaps just after the next election. I'm referring to the U.S. situation, not the Chilean situation. So what we really need is something which a term has been bandied around, but really risk informatics. This is a notion that there are going to be data systems, monitoring systems, systems that gather information from impacts. All of that needs to be brought together, not just in a formal way, but in a very informal way in terms of the discussion. In other words, we need to build up the appropriate evidence base for making decisions. That evidence base has to come from models, from worldviews, from scenarios, and from an understanding of the socioeconomic and the cultural context as well. That all has to be included as well. So when we talk about building a resilient economy or a resilient society, we really need to talk about partnerships. And in the center here, this is of course very schematic. We have resilience incentives and policies, which is generally a function of government or aligning with government initiatives at the local, national, and of course the stakeholder levels. There are issues having to do with non-government organizations and their ability to advocate for particular sectors of the problem. There's, of course, the private sector interested in this. And, of course, there's university research and education. And let me make a particular point there, which has already been made, is that the relationship between university research and education, I described, for example, some of the educational initiatives we're undertaking at Columbia to train the next level of managers, the next generation of managers. But how do you translate the frontier research that's done in many universities, especially in the University of Chile, which are very advanced in this field, to the private sector? And I could actually draw this arrow among all the other boxes on this diagram as well. And so let me begin my conclusion with an notion of this I part of the systematics of the enterprise that you've already discussed, the R, the D, and the I. The notion of innovation for resiliency. First of all, you need to align government policy, government priorities with academic research, with private innovation, and stakeholder values. There needs to be a broadening of economic activity. This has to do with the so-called resource curse, having to do with one particular resource or one particular industry dominating economic activity, but also sociocultural interactions to reduce the impacts of very sector-specific exposure and vulnerabilities, whether it be the mining industry or the fishery industry, trying to understand how those risks can be spread throughout society so that important pieces of domestic productivity are not impacted disproportionately. I would argue, and many have argued, I should say, that we need to encourage innovation hubs linking university research to resiliency strategies in both the private and public sectors, and increase in a very quantitative way, in a very technological way, something which you're already doing in the case of earthquake and volcano monitoring here. Monitoring, modeling, scenario building, forecasting, prediction studies, and linking these information products through an informatics system to practice and innovation. How is all the good work that's being done in the various enterprises around this problem being translated into actual advice, into actual policy, into regulation, into incentives? We see this globally happening in various degrees. There's notions of a green economy having to do with an environmentally clean economy, a so-called blue economy having to do with the health of the oceans. And of course, there's there are what I would argue are somewhat false distinctions between urban and rural economies, in the sense that the urban footprint often extends into the rural areas as well in terms of food and energy supply and so on. The point being that all of these can be coalesced into some understanding of what a resilient economy and adaptive economy need to be. So I begin with an example here, or I conclude with an example that we're beginning to see in China, of all places, sort of national resilience incubators. There's a resilience sector being developed which requires basic research incubators, university-based incubators, corporate, independent, and economic development incubators. These are actual physical enterprises, workshops, buildings, where people can get together, different representatives can get together and forge new solutions based on evidence, based on innovation, based on entrepreneurial spirit. This has to be aligned with the government sector, as I pointed to, but one of the issues here is that having rigid targets can lead to verification issues. So if you do insist on rigid targets, making sure you have the verification and the legal framework associated with that is also very important. The investments in resilience, whether it be in the public sector or the private sector, are in fact going to be tied to the visions of leadership. There's no question about that in my mind. That's certainly true in China. We're seeing that beginning to appear in other countries around the world. And there needs to be some government incentives that will incentivize public sector and private sector institutions to use new technologies and build new initiatives. How will that be defined? And I have some comments on that I can make. Let me simply turn up to one of the last slides here, which is the notion that the universities play a critical role. This has already been mentioned. I am biased from the standpoint of universities being involved in this discussion, but I think the reality indicates that it's absolutely necessary, given that much of the frontier research is being done in the universities. And this is modified by an excellent book by Pamela Matson. Which is the notion that there is a sector in this matrix where we no longer think of just simply applied research or basic research, what has simply been called pure science or engineering. That is a distinction that really has no difference when we talk about solutions-oriented research. The notion that feedbacks from society don't predict where the research is going to do, but help to define the problems that are being addressed, but also help take basic research that is driven by curiosity, and turn it into advice, translate it into advice that is relevant to the problem at hand. That can be done, and universities are beginning to realize that. There are examples being done. There are similar frameworks for this sort of discussion in about 20 countries globally, including China, as I pointed to, and there are various ways of implementing this that we can get into. So with that, I leave you here the notion that this is in fact a partnership, that Chile has already demonstrated that this partnership is in place. The question, of course, is whether this will be implemented, what will be the political will to implement it, and will everybody step up to the challenge at hand. Thank you very much.